Characteristics of the driver, the pedestrian, the vehicle, and the road. Introduction. Components of highway mode of transportation. There are four main components of highway mode of transportation. These are the driver, the pedestrian, the vehicle, and the road. The bicycle is also becoming an important component of design of urban highways and streets. One example is the bike lanes from Taft Avenue to Quirino all the way to Rojas Boulevard. Denmark is a country which is famous for using bicycle as a mode of transportation. Why is it important to note these characteristics? It is important to provide efficient and safe highway transportation. A knowledge of the characteristics and limitations of each of these components is essential. It is also important to be aware of the interrelationship that exists among these components in order to determine its effects, if any, that they have on each other. Their characteristics are also primary importance when traffic engineering measures such as traffic control devices are to be used in the highway mode. Importance of knowledge and characteristics. The road therefore must be designed to accommodate a wide range of vehicle characteristics, allow use by drivers and pedestrians with a wide range of physical and psychological characteristics. This chapter will also discuss the relevant characteristics of the main components of design and operation of highway facilities. One example in accommodating wide range of vehicles is in San Rafael, also known as Bantig, a barangay of Masin City. Way back in early 2000, the road is very narrow. Now that there are many moving cars along the road, it has to be widened to accommodate the variety of moving cars. Driver characteristics. One problem that faces traffic and transportation engineers when they consider driver characteristics in the course of design is the varying skills and perceptual activities of drivers in the highway, demonstrated by a wide range of abilities to hear, see, evaluate, and react to information. Abilities may also vary in an individual under different conditions, such as the influence of alcohol, fatigue, the time of day. It is important that criteria used for this design purpose may be compatible with the capabilities and limitation of most drivers on the highway. Both the 85th percentile and the 95th percentile have been used to select design criteria. In general, the higher the chosen percentile, the wider the range covered. The human response process. Action taken by drivers on a road result to their evaluation of and reaction to information they obtain from certain stimuli that they see or hear. It is therefore important that highway and traffic engineers have some fundamental knowledge of visual perception as well as hearing perception. Visual reception. The principal characteristics of the eye in visual acuity: peripheral vision, color vision, clear vision, and recovery and depth perception. Visual acuity. Visual acuity is the ability to see fine details of an object. It can be represented by the visual angles, which is reciprocal to the smallest pattern detail in minutes of arc that can be resolved and given as. Two types of visual acuity. First, Static. When both driver and object are stationary, background and brightness, color, contrast, and time are factors which affect it. Second is dynamic. Detect relatively moving objects. Drivers will see clearly devices within 12 degrees cone. Peripheral vision. Side visions, the ability to see objects and movement outside the direct line of vision. Objects outside this are not clear. Cone of peripheral vision can be up to 60 degrees. Speed of the vehicle and age of the driver also influences peripheral vision. Example, like when you look at the TV, you can still see the sides of you, but it is a bit blurry. Color vision. Ability to differentiate the color from another, not much significant as shapes as compensation. Combination of black and white and black and yellow have been shown in this shape. There are two types of clear vision. First is direct, when relatively bright light appears in the individual's field of vision, and the second is specular, when the image reflected by the relatively bright light appears in the field of vision. An example of clear vision is when you are driving a motorcycle at night. Then you came across another vehicle with the light on high. The light may cause discomfort and it can lose the visual performance. Clear vision recovery. Age has a significant effect on the sensitivity to glare. Glare recovery. The time required by a person to recover from the effect of glare after passing the light source. 3 seconds moving from the dark to light, and 6 seconds when moving from light to dark. To reduce glare effects. Location and street lighting should be well in design, higher mounting heights, positioning light support. By reducing luminaire brightness and increasing the background brightness. Restricting light so that there would be minimum interference of the visibility of the driver. The traffic control devices are standard in size, shape, and color as it aids in distance estimation and helps colorblind drivers. Depth perception, particularly important in two-way lane during passing maneuvers. Head-on crashes may result due to poor judgment. Important ability of the eye to differentiate between objects is fundamental to this phenomenon, but not good in estimating absolute values like speed, distance, size, and acceleration. It affects the ability of a person to estimate speed and distance. This is important in order to have good estimation of speed, distance, and etc., like when to slow down your speed. Hearing perception. Ear receives sound and stimuli, important in warning sounds like ambulance, traffic, police car. Can be corrected by hearing aid. When you take a driver's license, before you can take the exam, a physician will perform a medical, which he or she will check the ability of your eyes through eye test, and also he or she will perform ear or hearing test. Thus, having ear problems can be aided by a hearing aid. Perception reaction process. First is perception. Control device, warning sign and object of the road. 2. Identification. Driver identifies the object and understands the stimulus. 3. Emotion. Decides an action, brake, change of lane, etc. And the fourth is reaction or violation. The driver actually executes the action. Perception reaction time for P. Time elapsed during each of the sub-processes varies among individuals, vary for some person as location changes. Importance. In determination of braking distance, minimum sight distance is required on a highway. Factors. Situation complexity, environmental conditions, age, tiredness, drugs, stimulus if expected or unexpected. Diggs and Harris described the phenomenon in detail. They noted that the 85th percentile time to brake contained several situations varied from 1.26 to over 3 seconds. The reaction time selected for design purposes should, however, be large enough to include reaction time for most drivers using highways. American Association of State Highway and Transportation Officials asked to stipulate 2.5 seconds for stopping sight distances above 90% of drivers. Not suitable for unexpected or complex conditions such as road interactions, ramp terminals, or when signals are unexpected. Reaction time increases by 35%. Example: a driver with a perception reaction time of 2.5 seconds is driving at 65 miles per hour when she observes that an accident has blocked the road ahead. To determine the distance the vehicle would move before the driver could activate the brakes. The vehicle will continue to move at 65 miles per hour during the perception reaction time of 2.5 seconds. Solution. Older drivers' characteristics. As one grows older, sensory, cognitive, and physical functioning ability declines less safe than young. Declining abilities reduce visual acuity, ability to see at night, flexibility, motion range, reduced muscle strength, narrower visual fields. A higher probability of being injured when involved in crash, higher crash risk, greater sensitivity to glare, higher reaction times. For example, greater sensitivity to glare, longer reaction time, failure to respond to obstacles. Pedestrian characteristics. A pedestrian is a person walking rather than traveling in a vehicle. A pedestrian characteristic relevant to traffic and highway engineering practice because it has influence on design and location of pedestrian control devices. Control devices. Special pedestrian signals, safety zones and islands at intersections, pedestrian underpasses, elevated walkways, and crosswalks. Characters include visual, hearing, walking. Walking characteristics play a major part in design of controls. For example, the design of an all-red face which permits pedestrians to cross an intersection with heavy traffic requires knowledge of the walking speeds of pedestrians. Walking speed. Walking speed vary between 3 foot per second to 8 foot per second. By first factor is the gender. Walking speed for male is 4.93 foot per second. For female is 4.3 foot per second. Second factor is the population of elderly pedestrians. An average walking speed for design purpose of 4 foot per second if 20% or less elderly pedestrians Average walking speed for design purpose is 3 feet per second is greater than 20% are of pedestrians. Walking speed decreases with the increase of pedestrian density. Traffic engineer is responsible for designing a safe and suitable facilities for all pedestrians. Special consideration should be given to small children, senior citizens, physically handicapped, and blind. For blind pedestrians, special control devices should be installed, for example, ring bell signals that conveys to pass on red phase. Example, if you notice the traffic light, it takes at least a minute to 3 before it turns go. It's because the factor that some elderly may cross the street that will take more time than the younger ones. Pedestrian characteristics. For handicapped pedestrians, ramps are also now being provided at intersection curbs to facilitate crossing in the intersection by the occupant of a wheelchair. Average walking speed of a handicapped pedestrian can vary from low of 1.97 foot per second to 3.66 foot per second. Bicyclists and bicycle characteristics. The basic human factors discussed for the automobile driver also apply for the bicyclists and bike riders, particularly with respect to the perception and reaction. Unlike the automobile driver, the bicyclist is only for the driver of the bicycle, but he or she also provides the power to move the bicycle. The bicycle and the bicyclist therefore unite to form a system, thus requiring that both considered jointly. In Pakistan, 2.3 million motorbikes are included on roads every year for about 7,500 per day. Three classes of bicyclists, A, B, and C, have been identified in the Guide for the Development of Bicycle Facilities by AASHTO. First is experienced or advanced bicyclists are within Class A. 2 is less experienced bicyclists are within Class B. 3 are children riding on their own or with their parents are considered as Class C. Class A bicyclists typically consider the bicycle as a motor vehicle and can comfortably ride in traffic. Class B bicyclists prefer to ride on neighborhood streets and are more comfortable in designated bicycle facilities such as bicycle paths. Class C bicyclists use mainly residential streets that provide access to school, recreational facilities, and stores. For designing. In designing urban roads and streets, it is useful to consider the feasibility in incorporating the bicycle facilities that will accommodate Class B and C bicyclists. For example, based on the result of the studies conducted in Florida, Payne suggested the minimum design speed for bicycles on level terrain is 20 miles per hour, but downgrade speeds can be as high as 31 miles per hour, while upgrade speeds can be as low as 8 miles per hour. Payne also suggested the mean speed of bicycles when crossing the intersections from a stop position is 8 miles per hour and the mean acceleration rate is 3.5 foot per second square. Class B and C is a certain class to be considered because there are children involved and most of the bicyclists are not experienced.